Martin, thank you so much for agreeing to meet with me today and for welcoming me into your lovely home. It's a real privilege to meet you, and you're in an area that I know so little about, so I feel like I'm sitting very humbly at your feet.
Well, don't be too humble. It's great that you're here. Thank you very much for coming.
Thank you. What got you interested? How did you get started in this area?
Well, it wasn't a particular childhood aspiration. I was interested in numbers and nature as a child, and I turned out to be good at mathematics. And so when I went to university, I specialised in mathematics. And I realised that was a mistake because I wasn't a person with a mindset of the other students who were really going to be mathematicians. I like to think in a more sort of synoptic or synthetic way. And I was lucky that I had the chance to get into the subject of astronomy and cosmology at a time when it was really starting to develop very rapidly. I was lucky to be in a good university and to be there at a time when lots of things were new, and that means the experience of the old guys is at a heavy discount and young people can quickly make a mark. And so I was lucky in that respect because I'm talking about the mid-1960s. That's a time when there was the first strong evidence that the universe started with a big bang, and the first evidence that black holes might exist, and many other discoveries. But the pleasure in my career has stemmed from the fact that the pace of discovery has not slackened at all. My first 5 years as a very young scientist were exciting, but if you look at the most recent 5 years, there have been discoveries of gravitational waves from space, important new technique, and lots of evidence that there are planets orbiting around other stars, some of which may have life on them. So these are very exciting subjects, all in the last 5 years. So it's a great subject, and I like to say that astronomy is really a fundamental science. It involves the most fundamental aspects of the natural world, but also it's the grandest environmental science, because the night sky is the one feature of the environment which all humans throughout history have gazed at and wondered at and interpreted in their own way. So it's the one thing which we all have in common, wondering about the night sky.
Wonderful. In your book, Just Six Numbers, you've wrote about the wonderful properties of the universe that enable life to exist, this special earth that makes it hospitable to life.
Yes.
For someone like me who hasn't studied physics in any advanced way, can you explain that science?
Yes. Well, of course, we're coming to understand the various processes whereby from some hot, dense beginning, the universe expanded and stars condensed out from the primordial gas, and some of them made planets, and they also produced complex chemistry, etc. We've come to understand all this, and we realize that it's all a manifestation of the laws of physics, the laws of nature. And it's amusing to speculate about counterfactual universes where the laws were different, where gravity might have a different strength, or where chemistry was simpler, where only hydrogen atoms could exist, etc. And the main point of that book, which you mentioned, was to point out that it happens that the laws of nature allow complexity to emerge. To give you two examples where this wouldn't happen. First, supposing that there was only hydrogen and no other chemical elements, no periodic table, then you couldn't have any complicated structures, and there'd be no nuclear fuel for the stars, etc. And also, suppose gravity was much, much stronger. If it was much stronger, then anything bigger than an insect would get crushed, and no evolution would have happened. So we have to have certain constraints on the strength of the various fundamental forces and the way they behave in order to understand how this complexity, which manifests itself most extremely in the biological world, of course, could emerge from simple beginnings by a series of steps, each giving more complexity than the last one.
Yeah. I know you've done a lot of writing and thinking around the future of humanity and our brains and the development and the place that AI might play in that, and thinking to the future. thinking back, 17 years ago, you wrote the book Our Final Century.
Right, yes.
Will the human race survive the 21st century?
Yes, yes.
And you said in that there was a probability of extinction by the end of this century of around 50% for the human race.
Yes.
Do you still, what's your thinking on that now?
Well, I think we have a
17
bumpy
years on?
ride, I think, because the main theme of that book and my newer book called On the Future is that although the Earth's been around for 45 million centuries, 4.5 billion years, this is the first of those centuries when one species, namely the human species, has the future of the planet in its hands and could determine whether we bring this marvellous evolution to an end, or whether we can perhaps help to carry it forward to a new phase in the far future. We don't know. But this century is very special, and it's special because there are more of us on this planet, we're more empowered by technology, and we are able to affect the whole ecology of the planet, and also we are developing a society where even a few people could have so much power by bio or cyber technology that they could cause massive disruption. So the big problems of governance, given that's happening, and also problems of ensuring that we can cope with a growing population and avoid a breakdown of society. So all these challenges happen this century, and the worst case is, of course, wiping ourselves out, and that's very unlikely. But I do think we have a bumpy ride, because it's going to be very hard to cope with a world where even a few people can cause massive disruption. As I like to say, the global village will have its village idiots, and they will have a global range. And we've got to cope with that. So I think ethics has not kept up with our knowledge and our power.
So where do you think that religion can play a part in humanity's response to these things?
Well, I think first, obviously, the mystery and wonder of nature is something which I think any scientist appreciates more than the average person, because you know, if you just think of all the chemical reactions that are involved in a flower growing or insect flapping its wings, it's so amazing that this happens. And so the wonder and mystery of nature is something which, the more you understand about it, the more deeply you wonder at. So that's one thing. But I think apart from that, I think if we are trying to persuade the public to take action, we have to accept that politicians have difficulties, because they have an urgent parochial agenda, and to get them to make a sacrifice here and now for the benefit of people in remote parts of the world 50 years from now is a big ask. And they won't do that unless they feel the public's behind them. And so if we want to preserve democracies and at the same time take the long-term action which, as you know, is needed if we are to deal with potential climatic threats, then people have to care. And that's why we should welcome the campaigns by young people especially, which are helping to sensitize the public to the importance of these things. Because if the politicians realize that voters are behind them, they will do something like this. But the voters have to care and not discount the future too heavily. I mean, the problem is that in most business decisions you discount the future at 5% per year, so you don't care what happens after 2050. Whereas most individuals, if they think a bit, they realise they ought to care about the lives when babies born today grow old, and that'll be in the beginning of the 22nd century. So we need to think far ahead, and people need to care. And the great religions are helpful in that. I mean, I mentioned particularly the Catholic Church because I was involved in some of the input to the papal encyclical, which he published in 2015, and which was important in the lead up to the Paris Climate Conference in December of that year. The Pope got a standing ovation at the UN, and he's got 1 billion followers in Latin America, Africa and East Asia, The public and the politicians in those countries, they realized that there was some support for doing something to remove a risk and pay an insurance premium so that things didn't get too bad in the second half of the century. And so that was where religion helped. I think the public can help, these demonstrations help, and scientists, if they go public, can help. I think another example that I would quote is that plastics in the ocean, which is a separate environmental degradation which we need to worry about, that is something which wasn't on the agenda until recently, and the Blue Planet programs funded by David Attenborough had a big impact, especially the albatross returning to its nest and coughing up plastic for its young, which was an iconic image, rather like the polar bear and the melting ice floe was for the climate campaign. And I think because millions of people remember that image, that's why one of our less enlightened politicians, Mr. Michael Gove, was willing to propose legislation to reduce the amount of non-reusable plastic waste.
So it's up to...
Yes, so he felt he could do that and had support and wouldn't lose votes. And so I think the scientists or popularisers of science who get through to the big public, they have a very important role, because I know people who've been advisors to government ministers and things like that, and they have a hard time because the ministers do have an urgent agenda, and they won't necessarily give priority to someone who says that in 50 years this terrible thing will happen if you don't do something now. But if you're a scientist and can get through to a wide public, which ensures that the issue figures in the inbox of politicians, figures in the press, and involves the way people vote, then the politicians will do the right thing.
Yeah, so there's a place for everybody who's watching this interview. We all have a part to play in telling our politicians that these are issues we're concerned about.
Well, absolutely, because politicians will take action if they think they won't lose votes thereby. And of course, they tend to feel that people focus on the parochial or the short term. But if they realise that there are these long-term issues which will affect our children and grandchildren, etc., and the entire future of this planet, then they will take action.
You talked earlier about that wonder of the natural world, and that's one of the things that I aim to do in saying yes to life, is inspiring people, just this, the amazingness of life and of this space that we inhabit.
Utterly amazing.
Yeah, where do you see wonder? What gives you a sense of wonder?
Well, I think you're probably expecting me to say the scale of the universe, and that's amazing in a way. But I think it's the complexity of the biological world, and because one point I often make is that what makes things hard to understand is their complexity, not their size, and that an insect is far harder to understand than either an atom or a star. And so the real wonder is the complexity of the natural world, the layer upon layer of complexity in even the smallest insect, and what's emerged from evolution over nearly 4 billion years. I think I find that astonishing, and we're coming to understand many aspects of this, but the more we understand, the more amazing it is.
Yeah.
I mean, I think it's a mistake to think that that knowledge destroys wonder. I think it deepens the wonder. I mean, I'm sure if you realise that everything an animal does involves the interaction of zillions of cells, and in each cell lots of chemical reactions happening all the time, it makes it more amazing than it is if you don't know anything about the microstructure of animals. So I think science adds to the sense of mystery and wonder, and of course motivates us to try and understand it better. I mean, you understand a lot more now, but that doesn't diminish the wonder.
Can I just finish with the final question around hope? And I know we've touched on so many different things in the course of this interview. Do you have hope for a positive future for the Earth and our place in it?
I do. I'm anxious because there are these new risks which are emergent, and although science has allowed us to cope with lots of problems, and people are healthier, they live longer than they ever did, etc. There are new emergent risks which we have to confront now, and which didn't exist in the past, which could cascade globally. I worry that there's a new class of threats which, if they happened, would affect the whole world. In the past, you could have something which is catastrophic in a part of the world, but the rest went on unaffected, whereas we're so interconnected that something that's a disaster in one part of the world will cascade globally. That's the downside. But the motive for trying to avoid those catastrophes is one which I probably feel more deeply as an astronomer, because the one thing which astronomers perhaps perceive more than most educated people is the huge extent of the future. I think most educated people are now aware that the past is very long. We're the outcome of nearly 4 billion years of evolution on the Earth. But many people who believe that somehow think that we humans are the culmination, the end point of it all. Now, no astronomer could believe that, because astronomers know that the sun is less than halfway through its life, and the universe will go on much longer, maybe forever. And I like to quote Woody Allen, who said eternity is very long, especially towards the end. And so we are maybe not even the halfway stage in the emergence of wonderful complexity. And so if you look at things that way, then if something happened here on the Earth which foreclosed all future developments, that would be foreclosing developments far more wonderful than anything we've happened up till now. And so that makes me more motivated to ensure that we do escape the risks that we are confronting in this particularly dangerous century, a century which is dangerous because it's the first time that one species can determine the planet's fate.
Martin, thank you so much.
Okay.
Fascinating
So,
to hear
Okay.
from you.
Yeah.
We live in an amazing world and
we do.
an amazing universe, and to be able to have just this little bit of time to hear from you on it with all of your expertise has
Yes.
been wonderful. So thank you.
Well, thank you very much. And if I can make one more point, it's that people who are not experts in science shouldn't be frightened of the science, because it's true that the technical details of the mathematics are very complicated, and you need a lot of training before you can understand them. But what's important about science is the big ideas, and they can be conveyed to everyone. Just as you can appreciate music even if you can't compose it or can't even play it.
Yeah.
And so in the same way, even people who can't contribute to science and don't understand the details of the technicalities and the instruments on which we depend to make progress, they can understand the important ideas that come out of it. And it should affect the way they think about the world.
Which is a great relief to someone like me. So thank you very
Right.
much.
Thank you, Ruth.